Hi, I'm Cathal Fitzpatrick from VMware. VMware's RAN Intelligent Controller, or RIC, is helping operators to open up their radio access networks for programmability, transforming what was previously a closed environment into an open platform for the deployment of new services. There are actually two forms of the RIC. There is the non-real-time RIC, which we call the centralized RIC, and there's the near-real-time RIC, which we refer to as our distributed RIC. The centralized RIC is a management plane entity, and it's analogous to existing SON platforms. It can host applications that can automatically reconfigure an operator's network to improve performance and efficiency. The distributed RIC, on the other hand, is a control plane entity, and there's really no comparable system in existing networks. Applications or xApps that are hosted on the distributed RIC can directly control how individual users or devices interact with the RAN. xApp developers, therefore, need to have a really deep understanding of underlying radio access technologies. One such developer is Cohere Technologies, and I'm joined today by Art King, Director of Management and Marketing at Cohere, and my colleague Lance Uyehara, who's the Director of Product Management at VMware, to discuss how operators can benefit from using Cohere's applications and the VMware distributed RIC. You're both very welcome to today's call.
Yep.
So, Art, can I start by asking you to introduce Cohere and your background in RAN application development?
Sure. Cohere Technologies was founded in 2011 to develop the orthogonal time frequency space OTFS wireless system. And in 2018, we really looked at OTFS and realized that the mathematics and the core algorithms could be extracted from the OTFS system and used to improve the performance of both 4G and 5G networks. So, over the last few years, we've endeavored to package this up into an xApp and build and define and build the interfaces to the base station infrastructure in order to really provide a way to demonstrate our system and show the value of the what our xApp is called is the Universal Spectrum Multiplier.
Okay. So how can operators benefit from using the Universal Spectrum Multiplier xApp and the VMware distributed RIC? And what's the benefit to them from using that solution?
The spectrum is the oil of our industry. It's the most precious asset that the operators have, and it's an extremely finite resource. So with our xApp, we're able to increase the spectral efficiency and carry much more traffic and make the user experience better for the subscribers, in previously congested networks. Where we're really focusing right now is low band FDD infrastructure, where the problem in that beachfront spectrum is so significant that the idea of actually unplugging the pipes there is a compelling problem that the operators want to solve to satisfy the subscribers, and it's a very compelling place to inject our innovation into the low band infrastructure.
Very good. And Lance, what are the key capabilities of the VMware distributed RIC that companies like Cohere are using to support near real-time control over RAN functions?
Well, there's many aspects of our near real-time RIC that are really compelling and offers a lot of value to not just our customers, but to our partners, such as Cohere. VMware comes from that legacy of abstraction platforms, but just besides having this platform that's abstracting the underlying RAN and presenting these standardized interfaces, that allow these application partners to take advantage of the control and management of the RAN, we've taken it one step further than just our traditional abstraction platforms. We've architected and designed the near real-time RIC for, again, this near real-time performance. So just very low latencies. We have on the order of 2 millisecond round trip times within our interfaces. We've recently conducted some performance testing with a major tier 1 operator, where we demonstrated up to 100 E2 nodes, basically 100 base stations, if you will, being able to have transactions on the order of 5 millisecond type reporting times from all of these and still meet performance requirements. So I would say, just the way we've evolved these abstraction platforms and made it into a high performance platform now, and being able to support the applications such as Cohere, which has some very valuable value propositions, but then requires really precise timing and actuation of control within the RAN.
Yeah, cool. And Art, have operators seen benefits when they've tested your xApp in various trials?
Yeah, yes. In the trials we've been conducting, we've been working in venues of rural coverage, suburban coverage, and dense urban coverage. And in each of those scenarios, we've demonstrated significant capacity gains in the spectrum. And for us, when we use the RIC kind of to extend on Lance's comments, one of the important things for us is VMware allowed private interfaces to be built in the RIC to help us get over the bridge from pre-standard to standard. So there's some innovation capability that the platform allows to help people that are early on, especially where APIs don't quite exist yet on the base station, to bridge themselves through to the time of the standard.
Yeah.
And we found that particularly valuable in our development cycle.
Okay, cool. And you mentioned there the standardization work that's happening. So, can I ask you about where is the market at the moment, and how do you see the market developing?
Sure, I can take a first stab at that. I think the market is still in that technology innovation stage. We're still trying to demonstrate the value that the Near-RealTime and the applications can bring in. So companies like Cohere that have this very innovative technologies that can actuate changes in control in the RAN that wasn't available before, right? So these are customers, the mobile network operators, now have the ability to take advantage of these unique technologies from these small innovative companies and create big value in terms of what they can offer in terms of cost savings and spectrum efficiency. And I think we're still in that phase of getting that, messaging it out, evangelizing the market, gaining that market momentum to eventually where we can roll it out more in the mainstream.
Cool.
And for our part, what we see is the consensus building that we have to do as an industry with the operators around the value, and especially the value of providing a standardized interface. For any of us who are innovating, the idea of a lot of one-off APIs is just a kind of a development nightmare. It's both the development nightmare for the base station provider and also for the innovation community. So the idea of stable interfaces, and a platform like a RIC to essentially plug into is really compelling. But we're all, I think, as an industry, working towards eventual adoption of the E2 interfaces by the actual base station community, kind of driven by the consensus of the operators that this is a valuable thing that benefits their networks.
Great. Thanks, Art. So I'd like to thank you both for joining us here today. So as you say, Art, it sounds like a really compelling technology. So we're all looking forward to a rapid adoption in the market of this technology. And if anyone needs to find some additional information, there's lots of great detail available on the VMware website. So please contact us if you need to learn more. So thank you all for joining.